all those which are around us can be divided into a matter as well as energy. And what is matter? The one which has a mass and which can occupy space. And energy, you know, light is a form of energy, heat is a form of energy. Okay, they move through the space. Sound is a form of energy, right? Now, as far as momentum is concerned, a momentum is a property of a matter, the one which has a mass as well as the one which can move in the space, which has a velocity. Is that clear? This is the answer for those who have asked me, does light has a momentum? Right? So light is a form of energy. It cannot be considered as a matter, and matter has momentum. Right? And in the previous classes what we have seen, momentum depends on a mass and velocity, and we have taken an example that if suppose mass is of 10 kg and if it moves in velocity of 1 meter per second, then the product of mass and velocity is referred as momentum, which can be denoted as a capital letter P. And suppose if you want to calculate, right, momentum of a car which is weighing 1000 kg and moving in 1 meter per second in the starting, and then when it goes after some time, its velocity changes to 20 meter per second, but the mass remains 1000 kg, then we have taken this initial velocity as 1 meter per second and final velocity as 20 meter per second. So it is very easy now to calculate momentum at two different places, and the first place, that is when it has an initial velocity, so that momentum is called initial momentum, which is m into u, because u is initial velocity, which can be 1000 kg into 1 meter per second, and that is 1000 kg meter per second, which is the SI unit of kg meter per second, is the SI unit of momentum. Right. In the same way, final momentum, we have seen final momentum can be taken as m into final velocity, that is v. So 1000 into 20, that becomes a 20,000 kg meter per second. Right. So now we shall go for one problem. Now as far as problems are concerned, now you have to be very alert now, and these are the things, problem solving skill, which help you to score more marks. So now onwards, in science, in particularly physics, you will come across more of problems only. Problems, if you can solve the problems, that decides whether you have understood the theory part or not. So question here is, I am going little hurrying up now because we will take up the Newton's third law if possible now, and law of conservation of momentum. So as far as momentum is concerned, you can ask question in between if you feel like asking. What is the change in momentum? So change in momentum is question mark. And car weighing 1500 kg, so you can write m is equal to 1500 kg, right? And its speed increases from 36 km per hour to 72 km per hour. So it increases from, okay, sharing has gone, so I am reshare it.
Sir, we cannot hear you.
Sir.
Sir, we cannot hear. We can't hear you, sir.
Sir, your presentation stuck in between, sir.
Yeah. Okay, now can you see that?
Yes, sir.
Can you
Yes,
hear me
sir.
now? Can you hear me?
Yes, sir.
So it has come out of that sharing event, right? So m is 1500 kg, and what I was telling is a car which is already moving in 36 km per hour, and it changes its speed into 72 kilometer per hour. That means this is initial velocity, that is u equals 36 kilometer per hour, and v is equal to, tell me, 72 kilometer per hour. At this moment we have to be little bit alert, because you see mass is expressed in kg, but u is expressed, that is initial velocity is expressed in kilometer per hour, which you should convert it into. Can you tell me? Hello. Speak. Can you hear me? Hello? Hello? Can you hear me? Hello? 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 Can you hear me?
Yes, sir. Yes, sir.
What has happened?
Yes, sir.
Internet must have gone from my side.
Yes, sir.
Yes, sir.
Correct?
Whole
No?
side that
It's on
internet is
side of your notification screen. It is showing that we have problem in connecting to the
having
network.
internet problem.
Yeah, internet must have gone. That's what.
Off.
For a moment. Okay, we'll restart now.
Sir, again we should join, sir.
No. You, you are there already.
Yes, sir.
You're already there, no? You're already there.
You told restart na, sir. So
Okay, no, not required. Right? Okay. So, this much, did you hear this much? No?
Yes, sir, we heard, sir.
You heard.
You heard, sir.
Okay,
Yes, sir.
okay. Now I was about to ask a question that, when initial velocity is 36 kilometer per hour, just look at it. This is in SI unit. Mass is in SI unit. SI unit of mass is kg. But SI unit of velocity is meter per second. That means first thing what you have to do, convert this kilometer per hour into meter per second. Now tell me, how can we convert that into meter per second?
Sir, 5 divided by 18.
So we have to multiply by 5 by
multiplied by
18.
5 by 18.
So tell me the answer, how much? 18 ones are, 18 twos are, so it becomes 10 meters per second. Okay, in the same way,
10 meter per second.
the velocity is 72 kilometer per second. Quickly tell me now, 72 into 5 by 18.
Sir, how you took 5 and 18, sir?
Okay, who is asking? Akash. 5 and 18. I will separately tell this to you, right, after once we get it over. Right, you must have missed previous video tutorials. I will come back to you, right? But at this moment you just remember that 5 by 18 is the factor which you have to multiply to the number where you get convert into kilometer per hour into meter per second. So what is the answer here? 18 ones are 20 meter per second. So now we have, mass in SI unit, initial velocity in SI unit, and final velocity in SI unit. What we have to find is change in momentum. Change in momentum is equal to question mark. So therefore, change in momentum, so let me write, change in momentum is equal to, tell me the formula, final momentum
Initial
Momentum minus
velocity.
initial
Final momentum minus
Final-
initial momentum.
Yeah, final momentum minus initial momentum. And what is let me write initial momentum. So what is the final momentum? That is m into final velocity, right? V minus
V, sir.
initial momentum is m into
U.
u.
U,
And
sir.
that is equal to m is 1500 into v is 36, right? Minus, you can calculate from your side and tell me the answer of this quickly. And
Sir, V is 20 na sir.
okay, v is right. Sorry, v is 20, right. And this is m is again 1500 into u is 10. So keep calculating, make it fast. So this becomes
30,000, sorry.
30,000 minus
Sir,
15,000 minus
kg meter per second.
15,000
Yeah. So
kg
that
meter
final
per second.
answer will
15,000
be
kg meter per second change in momentum.
15,000 kg meter per second. Simple
Per
one.
second.
Okay, this is how we can
Sir,
do
one
this.
zero is missing, sir.
15,000.
15,000. Very good.
One zero is missing.
It has become correct now. Kg meter
Yes,
per
sir.
Yes,
second.
sir.
Okay.
Yes,
Now
Yes, sir.
next. A man throws a ball weighing 500 gram. Look at this, 500 gram. Again, mass of the ball is 500 gram. What should we do now?
Sir, convert it into
Kg.
kilogram, sir.
So how much is kg now?
0.5.
0.5 kg. That's the first thing which you have to do.
0.5.
Okay, that's the first thing which you have to do. And then, okay, what else is given here? Let me move this somewhere here. 10 meter per second. Speed is 10 meter per second. So initial velocity is 10 meter per second. Okay, what will be its initial momentum and what would be its momentum at the highest point of the flight? So what is done here is a ball is thrown vertically upward with a velocity of 10 meter per second, and that is initial velocity 10 meter per second. But remember, when the ball goes to a particular height, it reaches to the maximum height here, and when it reaches to the maximum height, the final velocity becomes zero, or its velocity becomes zero. That's why it starts falling down. Okay, so at maximum height, its velocity becomes zero. Right? Now what is asked?
How, sir?
What will be its initial momentum? Initial momentum is very simple. Initial momentum is equal to, keep telling me the answer now, is equal to mass
kg meter per
into
second.
u is
Sir,
equal
5
to,
kg meter per second.
yeah, into 10, that's equal to 5 kg meter per second. Okay, now momentum at highest point. So,
Zero.
can you tell me the answer?
No, sir. 0.5
Momentum
into
of
0 equal to 0.
highest
0 kg meter per second, sir.
point is equal to mass into velocity, and velocity mass is here 0.5 kg, but at highest point velocity is 0, the entire momentum will become 0.
0 kg meter per second.
Okay, the moment it comes 0, over. Right? Next.
Sir, why it became zero, sir?
Why no? It happens like that. You throw any ball, will it go forever into the space? So I am asking you why it is coming back after some time. It comes back after some time only when it becomes, velocity becomes 0. So it is velocity in this direction becomes 0. And then the moment it becomes 0, the earth will start pulling it downward, and again its velocity increases. Is that understood?
Yes, sir.
Okay.
So,
Now,
sir-
quickly we'll go for next one. Here what is given? A body of mass 25 kg. M is equal to 25 kg, and its momentum is given. P is equal to 125 kg meter per second. What is its velocity? Simple equation. How to do? We know that momentum is equal to
Meter per
m
second.
into v, and that is m into v is equal to p. So we want v is equal to p divided by m, which is equal to p is 125. Check the units, both are in proper units, that is SI unit divided by m, it is 25, that is equal to 5 meter per second. So these are the simple problems which you should remember, right, before we go for the conservation of momentum.
Sir, what is P?
P is, tell me what is P, others?
P is momentum, sir.
P is
Sir,
momentum.
T is momentum.
P is momentum.
P is momentum. Okay. Now another important concept, what is called conservation of momentum. Okay. I will make it very short now. What is conservation of momentum? And in the next period we will study in detail. Conservation. What do you mean by conservation? What is the meaning of conservation? Can you tell me?
Using, sir.
Saving, sir.
What is that?
Protecting.
To protect, to
Using,
preserve, to preserve,
sir.
not to
Protecting.
destroy, right? Not to destroy. Okay, that is the meaning of conservation. The law of conservation of momentum, momentum not to be destroyed, that's what it speaks. Momentum will not be destroyed, right? For example, let me give a very simple example here. Let's say a vehicle having a mass m is moving with velocity u1. Now just think, we have considered velocity is u1. Any letter we can consider. Here we have considered velocity u1. Why, you will come to know. And what is its mass? m1. Okay. And just before that, another vehicle is going whose velocity is u2 and which is moving with a mass m2, right? So this is another vehicle. So we have two vehicles whose initial velocity u1 and other vehicle initial velocity as u2, and previous vehicle that is whose mass is m1 and another vehicle whose mass is m2. That's why to differentiate we have taken u1 and u2. When we take a initial velocity as u1 and u2, what will be the letter which we can use for final velocity? Tell me.
V1 and V2, sir.
V1 and V2, but mass remains same vehicles. Okay, on road sometimes what happens, because u1 is little bit more here, so and there is no space here in between, so there is a chance of this vehicle A and hitting vehicle B, and that we call it as a collision. They hit each other. So let us take that. After they hit each other,
Sir, Avinash is waiting in lobby, sir.
yeah, Avinash is waiting in lobby. 5 people are waiting in lobby. Thank you very much. Okay. Now what happened here? There is a collision. There is an accident takes place. And after the accident also, these things will move. These vehicles will move. But they move with some other velocity. Right? Let me repeat. After the collision, still they will move, just like, you know, a ball which is moving here hits another ball, a ball A and ball B, and they collide here, A and B, they collide, and still they move, right, in different velocities. So here also same thing happens. Mass will be remaining same, okay, unless there is some damage and piece is thrown out. Let us consider masses remain same, but its velocity is v1 and its velocity is v2. Okay, so consider this situation. This is very important. Now we are coming very close to what is law of conservation of mass. I mean momentum. So can you tell me what is the momentum of this vehicle? Quickly, I want your answer.
P1, sir.
No, formula. Use mass and Velocity.
M1 into U1 equal to
Very good. M1 into U1. What is the momentum of this vehicle?
M2
2
into U.
into M2
M2
equal to
into U2. Right. What is the momentum of this vehicle?
M1 into the M1
1 into
V1,
M1
M1 and M2.
And what is the momentum of this vehicle?
M2 into
V2.
M2 into V2.
Right. You are properly understood now. Now we will come back to what is a conservation of momentum. Right. If I add this, that I can call it as total initial
Momentum.
momentum of both the vehicles, isn't it?
Yes, sir.
This is
Yes,
initial momentum of this vehicle and this one is the initial momentum of this vehicle. When you add this, it becomes total initial momentum of both the vehicles. Now tell me what will be this? Total
final momentum.
final momentum of the same vehicle after the collision. So here it is after the collision. Collision means accident, right? So what law of conservation tells us that in simple word, remember it is very easy to remember if it comes in the examination. See, momentum before collision. And what is momentum before collision?
Before
M1
accident, sir.
U1 plus M2 U2. Momentum before collision will always be equal to momentum. Finish my sentence. After collision. Okay. Now tell me what is the law of conservation of momentum? If two bodies collide each other, then the momentum before collision is
Same as the
is always equal to the total momentum after collision. So what is the use of this? Suppose you know the total momentum here, if you know this, okay? Suppose if you know this and then you know this, then you can find this. You can find, suppose if you can hit something by some object, okay, maybe two objects, if you hit, you can very easily find out what will be its speed after it hits by using this equation, which we are going to solve. And this is what law of conservation of momentum, right? Momentum before and momentum after. Momentum before it is M1 U1 plus M2 U2. Momentum after it is M1 V1 plus M2 V2, and conservation of momentum is M1 U1 plus M2 U2, that is momentum before collision, is always equal to momentum after collision. Okay, so suppose if you are asked to give a statement on what is, right, the law of conservation of momentum, this is a statement. However, I will be giving you the notes in detail. When two or more bodies, understood, it is more than two also, act upon each other, act means they interact, they collide upon each other, their total momentum remains constant. What does it mean? This, whatever was the initial momentum will remain same, means both will be equal. These velocities may change, they interchange, but the total momentum is conserved, and that is why it is called law of conservation of momentum. Very simple thing which you can notice before we go to Newton's third law of motion. Okay, if you have a carom board, you arrange the piece. You arrange the piece, not the striker, in a straight line, right? And take one piece. All pieces are of equal weight. Take one piece, you hit that piece. And all these are to be totally touch. They should be touching each other. Let me ask you, how many of you have got a carom board? Anyone has got?
In home,
I have, sir.
Okay.
sir, I have, sir.
Okay.
Yes, sir.
What I am telling, just post a video of this. Okay. So let me tell you now. Board should be very smooth. Powder should be there. Each of these pieces should be in touch. Okay. And then take another piece, not the striker, another piece and hit it. Hit it from this distance, some distance. Okay. But straight, not cross. And you will find this piece will move out. Okay, now another experiment. Same conditions. Take two pieces and hit this. From here you have to apply force. And you will find two pieces will move out. Take three pieces together and same thing you do. Push or knock it exactly like here. How many pieces should move out?
3, sir.
Three pieces should
Three
move.
pieces, three
Like
pieces.
this is the finest example of law of conservation of momentum. What is happening here is, see, when 3 can push 3, it means the momentum is
Equal.
conserved. Now, who will send me the video? Take a video from the top of the board. Some help you required. No shaking of video. And then we will see that video in the next class. Is it possible?
Yes, sir.
Who has told yes? Who has told yes? Okay, Abhishek. Abhishek has told yes. Right.
Sir.
And who else? Okay, now we will end this concept now. What we have learned here in this concept is about how to find out the momentum and what is the law of conservation of momentum. Next period we will go for Newton's third law of motion, and then after that many problems we need to
Level
solve.
100.
Okay, now I am going to close